We already did chapter 9 a while back. We're going to leave section 8.3. You guys got to get in there and try it. So section 8.3 is just a review of graphing lines, and you have one extra step. After you graph the line, you shade one side or the other. If I ask you, just look at me. If I ask you, what number do you square to get 9? Why is that kind of a weird question? Because 3 is an answer. What's another answer? Negative 3. So squaring is sort of like absolute value in the sense that the outputs are always positive. So if 4 squared is 16, negative 4 squared is also 16. I like it. I like it. So the square root symbol means the positive root. Because we understand there are 2 roots for every positive number, 0 number. There are 2 roots. So when they say right here, they say, what are the square roots of 25? 5 and? Negative 5. What about negative 4? What do you multiply by itself to get negative 4?
2 and negative 2.
2 times 2 is?
4.
Shit, doesn't work, does it? You didn't get negative 4.
Oh.
So remember, the square root of something is something that I multiply by itself to get that thing. So is there a real number that I can multiply by itself and get negative 4? What's negative 2 times negative 2?
4.
Still positive 4. Shit. This is kind of related to why I can't do a sum of squares. It's related to that. So, and let's see, why does that make sense? Real quick, on the side. Can you solve this equation? Yes, because what can I do with this? Factor it. Right? And then you get 2 and negative 2. Now look at another way to look at this. Couldn't I add 4 to the other side? And what do I square to get 4? 2 and negative 2. You guys with me? So what about if I had x squared plus 4 equals 0? I can't factor this, can I? So I'd say no solution. If I subtracted 4 over, this says what squared is negative 4. There's no real number that does that. So that's a nice way to go back and realize, oh, that's another reason why I couldn't factor this. Because there's no real answer to this equation. Maybe. So what are the square roots of negative 4? We would say not real. Because there are square roots of negative 4. There are. And they're not imaginary, even though that's their name. What's the square root of 0? That's the one number that has only one square root. Because there is no positive 0, negative 0. I like it. So what do you think about this? Let me ask you this right now. I think they ask you this on the next page, but let me see if you guys can get this. What's the square root of x squared?
X.
Why are you wrong if you think it's x? Because what could x be? X could be a negative number. And what we just get done saying, the square root symbol is the positive root. So when I see a square root symbol, it's called the principal square root. It says, give me the positive root. So the answer can't be negative. So how do I make sure the answer? So I can't just put an x. How do I make it always positive?
Absolutely.
Yeah, dude. That's the connection between roots and absolute values. There is a connection. Kind of makes sense because when I square something, it comes out positive. Okay. So this symbol, the square root symbol that we're so used to. Oh my gosh, look at that weird ass. Oh, this poor whole page kind of got crappy. Oh well. So this is the square root of 81. If I want the negative root of something, I have to actually put a negative sign. So this should be negative square root of 169. So if I said, what are the roots of 81? You would give me 2. What are the roots of 81? 9 and negative 9. If I have this symbol, that's understood to be the positive root. So what's the square root of 81? 9. What's negative square root of 81? There you go. That's how you get both. You have to be very explicit. I want the positive one or I want the negative one. Now, let me show you something that I showed my... I don't want to say this because you guys are going to freak out. I showed my calculus students this morning this. And so I'm going to show it to you because it's not calculus. It's just numbers. And I want to make sure that you guys have seen this at some point. Help me out. What's 1 squared? 1. What's 2 squared? 4. 3 squared? 9. What's the next number? 16. 25.
36.
Now watch this. How far apart are these? 3. How far apart are these?
5.
5. How far apart are these? What are those? 7. Come on, guys. How far apart are these?
The Fibonacci.
11.
No Fibonacci. Not that freaky. These are just... You killed her. These are just what kind of numbers? Odd numbers. You ready for something really cool? This is all on the side, and I don't know how you feel when I do this. Part of me doesn't care. I just want to show you so you see it in your lifetime. What's 12 squared? What's 11 squared? 121. How far apart are these? Another odd number, of course, but here's something really flippin' cool. What's 11 plus 12? 23. So if I want to know what 13 squared is, and I know what 12 squared is, what's 12 plus 13? 12 plus 13 is 25. If I add 25 to 144, I get 169. That is what 13 squared is. This is one of the basic things math does, is it looks for patterns so we can use them. Right? I don't know if many of you knew that 13 squared is 169. I'm sure a few of you get it. Maybe. So that would help with this. What's the negative square root of 169? Negative 13. What's up?
I'm just like, who created math? Like, it's just sometimes, I don't know, it's just crazy.
I know.
for me. I
The,
don't know.
the thing about numbers
All the
is
different
we
things.
didn't make sure this happened. It's just a consequence of us having numbers. Do you follow?
It just happened.
It just happened. So there's a ton of shit like this that you can exploit in some ways to make things quick to calculate, or they're just kind of like, well, that's weird, and then you move on with your life, right? There's a lot of stuff like that. We didn't build it in. It just is a consequence of us making numbers. There will be things. There's a huge search right now for, like, they're always looking for the next largest prime. Have you guys ever heard of that? They want to find the largest prime number, or the next largest, because it's already been proven there's an infinite number of them. But if you could find a pattern in the prime numbers, you would be like, a math rock star, which is really not that high up there, but still. You would make a lot of money. There'd be people that want to talk to you. So I've been doing that on the side, trying to find a pattern. Because there currently is no known pattern to the prime numbers. If you could find it, and some of you guys are like, what the hell's the use of that shit? If you got time, you're like, I'm playing with the numbers. But you never know how something can be used until you find it and see if it's useful somewhere. I mean, it's crazy. Yes?
So there are some things that you don't know, huh?
Oh, shit, yeah. Are you kidding me? It's funny how the more you learn, the more you realize you don't know. So it's sort of a, sometimes I'm like, if I could have just stayed ignorant, I wouldn't have had any clue how little I knew, right? I'm like, I'm happy. But I'm like, the more you know, you're like, shit, I don't know that whole thing. Anyway, but that's not something to be upset about. It's something to look into if it's interesting. And that is just one thing that was interesting to me. Okay, look here. So this is the same thing we had earlier, right? What's the square root of negative 4?
Not real.
Why is it not negative 2?
What is it, though? I'm curious.
Because negative
Does anybody know what the actual answer is? It's kind of lame in one respect, but I'm going to show you this kick-ass video that shows you some visuals about what they really are. The answer to that is 2i, because we define the square root of negative 1 to be I. I for imaginary. And real quick, the video I'm going to show you has a little bit of history. Do you guys know how negative numbers rule our life? As a college student, I know from my personal experience, the bank would not have been able to represent the amount of money I had without a negative number sometimes, right? You overdrafted, so we're going to take more money from you. What the shit? But when negative numbers were first thought of, almost everybody was like, well, that is bullshit. That is imaginary bullshit. How do you have negative apples? I got 3 apples, you take 5 apples from me. Explain that to me, person. But now, is anybody in here like, negative numbers don't exist? No, I'd hope not, right? We all know negatives and what they could mean. You guys with me? square root of negative numbers feels like it shouldn't have any physical meaning, but I'm hoping that we could talk a little bit about what they really mean. The name imaginary just is historical. People bought into it after it became standard to call them imaginary, which kind of sucks. Because as a student, you hear that and you're like, I knew all this shit was made up. You probably make shit up when we're just talking. But that's why I hate that. So anyway, I don't want to get too far down that hole right now because we're going to get into it later. Right now, if you see this question, you just write not real. Because that's the official designation of numbers that aren't imaginary. We call them real. It kind of makes sense. Real numbers. That's why we always say like all real numbers for some problems because you don't know the imaginary numbers yet. So you say not real. So this one would... In order to do this problem, can the negatives cancel each other out? No. Because you have to figure out what that is first and then put a negative on it. Can you figure out what that is?
11.
Not 11. Why is it not 11? Because it's the square root of negative. So what kind of number can you not take a square root and have it come out real? Negative numbers. I like it. So whenever you see the square root of a negative number, right now the answer is not real. What about square root of 0? 0. What about this weird thing?
3 over 4.
Yeah, square root of 9 is 3, square root of 16 is 4. Don't make any big deal about fractions. You just attack top and bottom separately. I like it. Oh, yeah, I knew they were going to do this. So now we know that that's going to be the absolute value of x. So what does the square root do to something? I want to lay this groundwork right now. What's the square root do to something? A square root of 9. It cuts it in. And I don't mean half additively, right? The answer isn't 4.5. Do you see what I mean when I say cut it in half? It's sort of like how do I factor a difference of squares? I cut everything in half, multiplicatively, right? So what would the square root of p to the 6 be? Now, could that be negative?
Yeah.
Totally. So what better you put on this sucker? Absolute values. If the answer to a square root could be negative, you better surround that sucker with absolute values.
If it's an odd number only, that means
I love it. Beautiful. So watch this. What's the square root of m to the 8th? So like you just said, could that be negative? Ain't no way. For a real number, we're only using real numbers, thank God, right? So you don't have to put absolute. If you did, I'd put a little note, not necessary. Right? Because any real number to the 4th power is going to be positive. Is that cool? If you have an even number of negatives, they team up and kill each other. So the answer is positive. I like it. So what do you think a cube root does to things? Cuts it in thirds, just like cubes, just like difference in sum of cubes. What do you think about this guy?
oh, you need this. Oh, is that
Absolute value of what? Yeah, totally. Cut x plus 2 squared in half. Okay, 1x plus 2, right? X plus 2 to the first, but you better put in absolute values because it could be negative.
Why can't the end of the word become an absolute?
It can, but it doesn't change it at all. Because m to the 4th already is always positive.
So then why did we put one on?
Because what if p is negative 2? What's negative 2 cubed? Negative 8. And the answer to a square root can't be negative. So if the result of the square root could be negative, you better slap absolute values around it.
Wouldn't that be the cube root?
I don't know why.
No. This is a square root right there, right?
Alright.
Okay. Square root of p to the 6, you cut it in half, and you get p to the 3rd power. Can p to the 3rd power be negative? Yes. If you put a negative value in for p, the result is negative. Is that cool? I'm not, okay. So p to the 3rd power. When is it negative? What's negative 1 to the 3rd power?
Negative 1.
Negative 1. So can p be p to the 3rd power? Can it be negative? Can the result to a square root question be negative? No. So you better put absolute values around this thing so the result is not negative.
What happens if there was a negative sign on the outside of the square root symbol, so you would mix the,
Then it would be this.
oh, so you'd keep the absolute value sign.
Totally. Let's try an example. Let's make p negative 2. So let's bring it back to just this, right? Here, remove this thing. All right. What if p is negative 2? So this is the square root of negative 2 to the 6th power. What's the square root of what's negative 2 to the 6th power? Let's think about it. I got to multiply 2 by itself 6 times. Well, all the negatives are going to
Positive.
cancel.
Yeah.
11. So let's just focus on 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32.
64.
Times 2 is 64. That's 6. I like it. So this is the square root of 64. And what's the square root of 64? 8. And 8 is 2 to the third. So you see the square root of p to the 6th is not always p to the third. Isn't the absolute value? It's not negative 2 to the third. It was positive 2 to the third. So you better put the absolute value around so it actually matches what it would be. So putting this absolute value is not making it positive. It's actually saying, I know the answer will be positive for any number I put in there. Because what do I get when I raise it to a 6th power? I get a positive number. Right? And then the square root's going to be positive. So I have to put absolute values to show everybody, yes, the answer will be positive. I can't mess with that. Okay. Blah, blah, blah. So now here's the last thing we'll do. I'm going to graph this sucker. Now they kind of misled us a little bit. What's the lowest number I can take a square root of? 0. I love it. Right? Can't take a square root of a negative number yet. We haven't talked really about complex numbers. And you don't even know how to graph that weird shit. This is a real plane. So the square root of negative 1 is undefined or not real. One or the other. So you can't do that. What's the square root of 0? 0. Square root of 1. 1. Square root of 4. 2. Square root of 9. 3. So don't I have points now that I can graph? I made an XY table, right? So 0, 0. 1, 1. 4, 2. 9, 3. And the next one, the next number I could use would be what? To get a nice answer. So next square up. 16. Well, that's way the hell off of there, right? So look what the shape is. What's this look like? If you turn it this way, it looks like a parabola. Like parabola fell over and lost its bottom half. Sounds like some celebrities' nights. So that looks like a parabola. Why does it make sense it looks like a parabola, sort of, that's been kind of moved around? Because a square root is like the opposite of a square. And what's a square look like? Parabola. So their graphs should be related to each other. Yes, sir?
The other half of the problem would be imaginary numbers, right?
I love it. So there's no... there's a whole other thing we don't see. Because we only graph real numbers. The real numbers fit on a 2-dimensional piece of paper. We'd have to have at least one more dimension to graph complex shit. Yeah. This stuff just doesn't exist. Why doesn't this stuff down here would be if the function was negative square root of x. Then I would get the other kind of half of the parabola, right? Yes, sir?
I'm just asking because I know I'm going to get confused. Why did you have the x squared as the y values and the regular x as the x values? Is there any reason? Or it's just
Where's that? Sorry.
on the table? Y was 2 the y value and 4 the x value. What was 9 the x value? What was 3 the y value? Just
Because what is the square root of... If I try to make 3 the x value, what's the square root of 3? Not nice.
Yeah.
So my function is square root of x. So what will I put in for x? Numbers that are easy to do the square root of. What numbers are easy to do the square root of are square numbers. because it just undoes the square, right? So if I put 4 in, I'm going to get back to 2. If I put 9 in, I'm going to get back to 3. So this is the idea of the square root being the opposite of a function that we know. Square root is the opposite of square. So I put here what would have been the outputs to a square question, because this is the opposite of that.
So the numbers you plug in yourself are always going to be x values, and the numbers that are the
Yeah, it depends on the way they but this is f of x equals square root of x. So my input is the number that goes inside. Yeah, so I want to use numbers that I can actually do the square root of.
okay.
I like it. Okay. So what's the domain of this function? What's the domain mean again? All the x values I'm allowed to use. What's the lowest x value I'm allowed to use? 0. Up to what? Infinity. What's the smallest output that I get? 0. What's the biggest output I'm going to get? This goes up really slowly.
Infinite.
Infinity. Yeah, how do I get up to 7? I have to put in a 49, right? How do I get up to 10? I got to put 100 in. So is there any output that I can't get? No, I just square it, and that's what I'm going to put in. So it goes from 0 to infinity for the range also. I like it. All right. That's enough for today. So don't forget on Thursday, what was it? Thursday we're going to have that quiz on chapter 8.
Excuse me, do you have the answer sheet for this?
Yeah, they went over it.
Is it this one?
Yeah.
Yeah, I can just take a picture. I
Good,
don't have to
okay.
take it with me. Can I ask you about homework? Chapter 8 to... Thank you.
All right.
Yeah. I don't know how to find it.
So you graph x less than or equal to -6. And the graph x greater or equal to 6. And it's an or, so it's going to be both of them. Yeah, so it's... Yeah. So now you just take one graph and graph both of them on the same graph. That's or. And would be, you graph them and you see where they agree. Where do they, like, overlap. Or is just like graph everybody. Yeah, normally it's going to be two separate answers. But sometimes it could be... So if I said, like, x greater than 1 or x less than 2.
You just said like,
Greater than 1, so it's this, or less than 2, so it ends up being everything. It's all real numbers.
wait.
So there's like certain situations where it's more extreme. Oh, they're still going.
Yeah.
Everybody's leaving. Ah.